Picture this: a cosmic traveler that graces our skies every 75 to 76 years. Like clockwork. This isn't science fiction. It's a reality that has captivated humanity for millennia. Imagine a celestial body so regular in its visits that ancient civilizations could predict its return, yet so mysterious that it continues to baffle scientists to this day. This celestial messenger has been both revered and feared throughout human history. Its appearance in the night sky has inspired awe, sparked panic, and even been seen as an omen of great change. From ancient China to medieval Europe, this visitor from the outer reaches of our solar system has left an indelible mark on human culture and scientific understanding. Ladies and gentlemen, welcome to the extraordinary journey of Comet Halley, the most famous intruder in our solar system. This cosmic spectacle has been witnessed by countless generations, each appearance etching itself into the annals of human history and scientific discovery. But what if I told you that this isn't just any celestial object? What if I revealed that this cosmic wanderer was observed by ancient civilizations, inspired countless works of art, and was even used to predict the fall of kingdoms? Imagine an astronomical body so significant that its next visit is already scheduled for the year 2061. That's right, we're talking about a cosmic event that transcends generations, connecting our past to our future in a celestial dance that has played out for thousands of years. Today, we're going to unravel the secrets of Comet Halley and understand why it has captured human imagination for millennia. We'll explore its rich history, its scientific significance, and the cultural impact it has had across different civilizations and eras. From the ancient Chinese astronomers who first recorded its appearance to Edmund Halley, who predicted its return using Newton's laws of motion, we'll trace the path of human understanding alongside the path of this remarkable comet. We'll delve into the panic and excitement that accompanied its appearances, the scientific missions that have studied it up close, and what we hope to learn from its next visit. So, buckle up for a cosmic journey that spans thousands of years and billions of miles. Get ready to see the night sky in a whole new light as we explore the legacy of Comet Halley, the celestial time traveler that has been a constant companion to human civilization. If this cosmic voyage has ignited your curiosity like the tail of a comet streaking across the night sky, then you're in for a treat. Join us on Exploring the Universe for more celestial adventures and mind-bending discoveries. Don't forget to like this video and subscribe to our channel to ensure you never miss an episode. Together, let's continue to explore the wonders of the cosmos and unravel the mysteries of our universe. The next fascinating journey through space and time is just one click away. Comets are often described as dirty snowballs hurtling through space, but this simple description belies their complexity and importance in our solar system. Let's break down what comets really are and how they function. At their core, comets are celestial objects composed primarily of ice, dust, and rocky particles. These cosmic wanderers originate in the outer reaches of our solar system, in regions like the Kuiper Belt and the hypothetical Oort cloud. As they travel through space, they carry with them primordial materials from the early formation of our solar system, making them invaluable time capsules for astronomers and planetary scientists. To truly understand comets, we need to examine their structure. A comet consists of three main parts. This is the solid core of the comet, typically a few kilometers in diameter. It's composed of ice, water, carbon dioxide, methane, and other frozen gases, dust, and rocky particles. The nucleus is often described as a dirty snowball due to this composition. As a comet approaches the sun, the heat causes the ices in the nucleus to sublimate directly from solid to gas. This process releases dust particles, creating a fuzzy, atmosphere-like envelope around the nucleus called the coma. The coma can extend for thousands of kilometers. Perhaps the most distinctive feature of comets, the tail, or tails, can stretch for millions of kilometers. Comets actually develop two types of tails. Composed of ionized gases, it appears bluish and always points directly away from the sun due to the solar wind. Made up of tiny dust particles, this tail is often curved and yellowish, as it reflects sunlight. The formation of a comet's tail is a direct result of its interaction with the sun. As a comet approaches the inner solar system, several processes occur. Solar radiation heats the nucleus, causing ices to sublimate and release trapped dust particles. The solar wind, a stream of charged particles from the sun, interacts with the gases in the coma, ionizing them and pushing them away from the sun, forming the ion tail. Radiation pressure from sunlight pushes smaller dust particles away from the comet, creating the dust tail. These processes result in the spectacular displays we see from Earth, with comets sometimes visible to the naked eye, their tails stretching across the night sky. Comet Halley holds a unique place in human history, having been observed and recorded for millennia. Its regular appearances have left an indelible mark on various cultures and civilizations. The earliest confirmed observation of Comet Halley dates back to 240 BCE in China, recorded in the Shi-Chi and Wenxin Thung Cao chronicles. However, it's possible that even earlier sightings were made. Babylonian clay tablets from 164 BCE and 87 BCE also contain probable references to the comet. These ancient observations demonstrate the comet's long-standing relationship with humanity. Chinese astronomers meticulously recorded its appearances, noting its position and movement across the sky. In Babylon, astrologers interpreted the comet's appearance as omens, often associating them with significant events or changes in leadership. One of the most famous historical depictions of Comet Halley appears in the Bayeux Tapestry, a 70-meter-long embroidered cloth that narrates the Norman conquest of England in 1066. The tapestry shows the comet in the sky, with people pointing at it in awe. The inscription reads Esti mirant stella, meaning these people marvel at the star. This representation is significant because it demonstrates how the comet was viewed as a celestial omen. In this case, it was seen as a portent of King Harold's downfall and William the Conqueror's victory at the Battle of Hastings. This illustrates how comets, and Halley in particular, were often interpreted as signs of momentous events or changes in the course of history. Comet Halley's regular appearances approximately every 75 to 76 years have allowed it to leave a lasting impression on human culture. 12 BCE. The appearance may have inspired the Star of Bethlehem in Christian nativity stories. 451 CE. Its passage coincided with Attila the Hun's invasion of Gaul and the Battle of Chalons. 1456. Pope Calixtus III allegedly excommunicated the comet as an agent of the devil, fearing it heralded the Ottoman invasion of Europe. 1682. Observed by Edmund Halley, leading to his prediction of its return and the comet being named after him. 1835. Inspired Mark Twain, who was born during its appearance and predicted correctly that he would go out with it during its next return in 1910. 1910. Caused widespread panic due to erroneous reports that Earth would pass through its tail, potentially exposing people to toxic gases. 1986. The most recent appearance, marked by an unprecedented international effort to study the comet up close with spacecraft. Each appearance of Comet Halley has contributed to our scientific understanding and cultural mythology. From ancient fears and superstitions to modern scientific study, Halley's comet has been a constant companion in human history, bridging generations and inspiring countless stories, artworks, and scientific endeavors. Its regular returns have allowed humanity to move from fear and superstition to scientific understanding and exploration, making Comet Halley not just a celestial object, but a measure of human progress and our evolving relationship with the cosmos. Edmund Halley, 1656 to 1742, was an English astronomer, mathematician, and physicist who made significant contributions to various scientific fields. Born in Haggerston, London, Halley showed an early aptitude for mathematics and astronomy. He attended Oxford University, where he published his first scientific paper at the age of 19. Halley's scientific pursuits were diverse and impressive. He catalogued stars in the southern hemisphere during an expedition to St. Helena. He made important contributions to geophysics, including work on trade winds and monsoons. He invented the diving bell for underwater exploration. He played a crucial role in the publication of Isaac Newton's Principia Mathematica, even funding its printing. However, his most famous contribution was his work on comets, which would ultimately lead to one bearing his name. In 1705, Halley published a synopsis of the astronomy of comets, a work that would revolutionize our understanding of these celestial objects. By analyzing historical records and his own observations, Halley noticed striking similarities between comets observed in 1531, 1607, and 1682. Halley's groundbreaking hypothesis was that these weren't different comets, but the same comet returning periodically. This was a radical idea at the time, as comets were generally thought to be one-time visitors to the inner solar system. Halley's prediction was based on a meticulous application of Newton's laws of motion and universal gravitation. Here's how he did it. He used historical records to plot the orbits of the comets from 1531, 1607, and 1682. Applying Newton's laws, he calculated the gravitational effects of Jupiter and Saturn on the comet's orbit. He accounted for these perturbations and calculated that the comet should return every 75 to 76 years. Based on these calculations, Halley predicted the comet would return in 1758. Though Halley didn't live to see it, the comet did indeed return as predicted, first spotted on Christmas Day, 1758. This confirmation solidified Halley's place in scientific history and led to the comet being named after him. Halley's comet has a highly elliptical orbit that takes it from beyond Neptune to well inside Venus's orbit. At its aphelion, farthest point from the Sun, it's about 35 Australian dollars from the Sun. 1 Australian dollar is the Earth-Sun distance. At perihelion, closest approach to the Sun, it comes within 0 Australian dollars and 60 cents. The 75 to 76-year period is a result of this elongated orbit and the gravitational influences of other bodies in the solar system. The long axis of the orbit determines the basic period. Gravitational perturbations from Jupiter and Saturn slightly alter the orbit each passage, accounting for the variation in the exact period. Thanks to the 1986 flyby missions, particularly ESA's Giotto probe, we have detailed information about Halley's nucleus. Size: approximately 15 by 8 by 8 kilometers. Shape: irregularly shaped, often described as a cosmic potato. Composition: a mix of volatile ices, water, carbon dioxide, methane, and non-volatile dust and rocky particles. Albedo: very dark, reflecting only about 4% of incoming light. Rotation: the nucleus rotates once every 2.2 days. Each time Halley's comet passes close to the Sun, it undergoes significant changes. As it nears the Sun, its ices begin to sublimate, creating the coma and tail. It loses about 1% of its mass each passage, ejecting gas and dust. The heat causes cracks and shifts in the surface, potentially exposing new areas of ice. Interactions with planets, especially Jupiter, can slightly modify its orbit. Jets of gas escaping from the nucleus can act like thrusters, slightly altering the comet's rotation and trajectory. These changes mean that each return of Halley's comet is slightly different, making ongoing observations crucial for understanding its evolution and the broader processes affecting comets. If this cosmic journey is making your curiosity shine as brightly as a comet's tail, why not join our orbit? Give this video a like and subscribe to our channel for more celestial adventures. By becoming part of our community, you'll ensure you never miss out on the latest cosmic discoveries and mind-bending space phenomena. Let's continue to explore the wonders of the universe together. The 1986 return of Halley's comet marked a watershed moment in cometary science. For the first time in history, humanity was prepared to study this celestial visitor up close. The event sparked an unprecedented international collaboration, resulting in what became known as the Halley Armada. This fleet consisted of 5 spacecraft from various space agencies: Vega 1 and Vega 2, Soviet Union; Giotto, European Space Agency; Suisei and Sakigake, Japan. Additionally, NASA's International Cometary Explorer, though not specifically designed for Halley, was redirected to study the comet from a distance. This coordinated effort represented a remarkable example of international scientific cooperation during the Cold War era. Each mission had specific objectives, ranging from imaging the nucleus to analyzing the comet's composition and studying its interaction with the solar wind. Among the Halley Armada, the European Space Agency's Giotto mission stands out for achieving the closest approach to the comet's nucleus. Named after the 14th-century Italian painter who depicted Halley's comet in a nativity scene, Giotto provided groundbreaking insights. Giotto came within 596 kilometers of Halley's nucleus on March 14, 1986. It captured the first detailed images of a comet's nucleus, revealing its irregular potato shape. Giotto's instruments analyzed the gases and dust particles in Halley's coma. Despite being hit by dust particles and temporarily losing communication, Giotto survived the encounter and continued its mission. The Halley Armada missions revolutionized our understanding of comets. We learned that Halley's nucleus is dark, irregularly shaped, and larger than previously thought. The missions confirmed that comets are indeed composed of ice, dust, and rocky particles, validating the dirty snowball model. We observed jets of gas and dust erupting from specific areas of the nucleus, not uniformly across its surface. The missions provided valuable data on how the solar wind interacts with the comet's coma and tail. The data supported theories that comets contain primordial material from the early solar system. The missions pushed the boundaries of spacecraft design, particularly in protecting against high-speed dust impacts. Halley's comet has often been a source of fear and superstition. Comets were often seen as harbingers of doom, war, or the death of kings. The 1066 appearance, depicted in the Bayeux Tapestry, was seen as an omen of the Norman conquest of England. This appearance caused widespread panic due to erroneous reports that Earth would pass through the comet's tail, potentially exposing people to toxic gases. Some entrepreneurs even sold comet pills to protect against these supposed effects. Various groups have interpreted the comet's appearances as signs of the apocalypse or alien visitations. Halley's comet has left an indelible mark on human culture. Giotto di Bondone, the Italian painter, is believed to have used Halley as the model for the Star of Bethlehem in his fresco Adoration of the Magi, circa 1305. William Shakespeare. References to the comet in his play Julius Caesar are thought to allude to Halley's 1607 appearance. Mark Twain. The author famously quipped that he came in with Halley's comet in 1835 and expected to go out with it in 1910, which he did. H.G. Wells. His novel In the Days of the Comet, 1906, uses a fictional comet's passage to trigger worldwide social reform. Visual arts. Numerous paintings, tapestries, and later photographs have captured the comet's appearances over centuries. The 1986 appearance of Halley's comet was highly anticipated but ultimately disappointing for many observers, especially in the northern hemisphere. Several factors contributed to this. The comet's 1986 path brought it to the opposite side of the Sun from Earth at its closest approach, making it appear dimmer. Increasing urbanization and the resulting light pollution made it harder to see the comet from many locations. Many people expected a spectacular show based on historical accounts and media hype, leading to disappointment when the reality was less dramatic. The comet was most visible in the early morning hours, which was inconvenient for many observers. Poor weather in many regions further hampered visibility. Despite these challenges, the 1986 appearance was a boon for scientific study, even if it didn't provide the visual spectacle many had hoped for. While 2061 may seem distant, it's never too early to start planning for Halley's next visit. The comet will be more favorably positioned for viewing from Earth. Consider traveling to areas with dark skies, possibly in the southern hemisphere, for best visibility. Advances in amateur astronomy equipment will likely make observation easier. Familiarize yourself with the latest telescopes and imaging technology. The comet will become visible months before its closest approach. Begin your observations early to track its development. Connecting with experienced observers can provide valuable insights and shared resources. Follow updates from professional astronomers and space agencies as the approach nears. Remember that while Halley is famous, it may not be the brightest comet you'll ever see. Appreciate it for its historical significance. Amateur astronomers play a crucial role in cometary science. Many comets are first spotted by amateurs. Regularly scanning the sky can lead to new comet discoveries. Consistent observation of known comets helps track their development and behavior over time. Amateurs often detect sudden brightness increases in comets, alerting professionals to significant events. High-quality amateur images contribute to the scientific record and can reveal important details about a comet's structure and activity. Participating in organized projects allows amateurs to contribute data to larger scientific efforts. Amateurs play a vital role in educating the public about comets and astronomy in general. Many professional amateur, pro-AM, collaborations exist, allowing amateurs to directly support professional research. Discovered in 1995 by Alan Hale and Thomas Bopp, Hale-Bopp became one of the most widely observed comets of the 20th century. It was visible to the naked eye for a record 18 months. Its nucleus was estimated to be 60 to 80 kilometers in diameter, much larger than most comets. It displayed distinct blue ion and white dust tails. Its appearance sparked widespread public interest and, unfortunately, was linked to the Heaven's Gate cult mass suicide. Its long period of visibility allowed for extensive study, advancing our understanding of cometary composition and behavior. In July 1994, fragments of comet Shoemaker-Levy 9 collided with Jupiter, marking the first direct observation of an extraterrestrial collision of solar system objects. It was found in 1993 by astronomers Carolyn and Eugene Shoemaker and David Levy. Tidal forces from Jupiter had broken the comet into at least 21 discernible fragments. The collision was observed worldwide, with visible marks left on Jupiter's atmosphere. The event provided invaluable data on both Jupiter's atmosphere and the composition of comets. It heightened awareness of the potential threat of cosmic impacts on Earth. Comet Neowise, C/2020 F3, became an unexpected naked-eye comet visible from the northern hemisphere in mid-2020. It was first detected by the Neowise Space Telescope in March 2020. It unexpectedly brightened to naked-eye visibility, becoming the brightest comet visible from the northern hemisphere since Hale-Bopp. Its appearance during the COVID-19 pandemic provided a welcome distraction and outdoor activity for many. It remained visible to the naked eye for about a month, allowing extensive public and scientific observation. With an estimated orbital period of about 6,800 years, its next appearance won't be until around the year 8786. Its unexpected brightness allowed for detailed study, providing new insights into cometary behavior and composition. Comets have played a significant role in shaping human beliefs and cultural narratives across civilizations. Comets were often seen as celestial messengers of the gods, portending significant events. Comets were carefully recorded and often interpreted as omens. The appearance of a comet could be seen as a sign of the emperor's mandate of heaven being questioned. Comets were generally viewed as harbingers of disaster. Aristotle's view of comets as atmospheric phenomena persisted for centuries. Comets were often associated with the deaths of kings or the onset of calamities. The appearance of Halley's comet in 1066 was seen as an omen of the Norman conquest of England. Many Native American tribes viewed comets as portents of change or harbingers of important events. While scientific understanding has replaced many superstitions, comets continue to captivate public imagination and sometimes spark apocalyptic fears or New Age interpretations. Comets have been crucial in developing our understanding of the solar system's origins. Comets are often described as cosmic time capsules, containing material largely unchanged since the solar system's formation. The existence of these comet reservoirs has helped shape our understanding of the solar system structure and evolution. Observations of comets have contributed to the development of this model, which explains the current configuration of the outer solar system. Comets are thought to have played a role in delivering water and organic compounds to the early Earth and other planets. Studying comet orbits has enhanced our understanding of gravitational interactions within the solar system. The role of comets in potentially seeding life on Earth is a fascinating area of study. Some theories suggest that comets, along with asteroids, may have delivered a significant portion of Earth's water during the late heavy bombardment period. Comparisons of the deuterium to hydrogen ratio in Earth's oceans and in comets have provided insights into the possible cometary contribution to Earth's water. Comets contain complex organic molecules, including amino acids, which are building blocks of life. Some researchers have proposed that comets could have delivered not just the ingredients for life, but potentially life itself, in the form of microorganisms. Missions like Rosetta to Comet 67P/Churyumov-Gerasimenko continue to provide data on cometary composition, refining our understanding of their potential role in life's origins. If this journey through the legacy of Halley's Comet has awakened your explorer spirit, you're on the right path. Continue exploring the wonders of the cosmos with us at Exploring the Universe. Don't forget to leave a like and subscribe for more celestial encounters and fascinating discoveries. Remember, every like, share, and subscription not only supports our channel but also contributes to spreading the awe and wonder of the universe. Together, we can inspire the next generation of astronomers, scientists, and cosmic thinkers. Who knows? Among our viewers might be the very minds who will lead humanity's exploration of Halley's Comet in 2061. So, stay curious, keep looking up, and let's continue our cosmic adventure together. The universe is vast, and there's always more to explore. See you in our next video, where we'll unravel another mystery of the cosmos.